Have you ever wondered how it's possible for machines to learn to perform seemingly impossible tasks or to do things that you would only think a human is capable of learning, like playing video games or learning how to walk in a simulation? Well, it can actually be all achieved through the use of genetic algorithms. Genetic algorithms can be used for a wide range of purposes, from simulating bacterial evolution to teaching neural networks to play Pong, which we've actually done in some of our previous videos. How these algorithms work is quite simple and can be shown through an analogy. So, imagine that you were on a mission to make the fastest car ever, but you have no previous knowledge whatsoever about what could contribute to making a fast car, and all you have to start off with is 500 completely random cars. To begin with, you would first test the speed of all of the cars by, let's say, drag racing them and recording their maximum speed. What this is actually doing in terms of machine learning is finding the fitness of the car, so the maximum car speed is its fitness. Now that you know which cars are faster and which ones are slower, you can put them in order based on their fitnesses. And this is the point where genetic algorithms are quite clever. What happens is you would take a copy of parts from, let's say, the top 100 cars and recombine them with other copied parts of other cars within the top 100 until you have made 500 cars. So that could be like taking the wheel from the 5th place car, and the body from the 63rd place car, and the engine from the 43rd place car. The new batch of cars is called a generation, and the parts that you combine to make up each new car are like the genetic code of the car, hence the name genetic algorithm. And this all works because you are only taking parts from the top 100 cars, so the 400 other cars that were ranked slower are not in it because their parts are not adequate to be fast enough. So the faster parts move on and the slower parts are left behind. And all this rearranging is done because, remember, you have no idea what makes a fast car fast. So by taking the best of each generation, you in return get cars with more ideal components for speed. And so basically, for the algorithm to run its full course, you would re-drag race all the cars from the new generation, order them based on their fitnesses, use the top 100 to make the new generation of cars, and repeat this process over and over until you're getting some pretty fast cars. This will work well, but there is a problem. After you create so many new generations, all the cars will start to look like the exact same car, and this is why there is actually one more part to genetic algorithms. So, let's rewind to the point when you are copying the parts that you will be putting into the new car. And let's say that you make a mistake as you are copying over the part because, not everyone's perfect. This is called a mutation, and they're actually not that bad. Yes, they can make the car worse, but that alteration could also be beneficial. In the end, it increases the variation so that not all the cars will end up looking the same, but it also gives you a chance to produce a car that is way faster than it could have with just the parts from the original 500 cars. And that's pretty much how genetic algorithms work. You can just see how versatile they are, because instead of using car parts, it could be anything from the weights of a convolutional neural network to the genetic code of a bacteria that determines how it acts in a simulation.